Welcome to the gas laws lesson. Let's start with Boyle's law. So Boyle's law is pressure 1 volume 1 is equal to pressure 2 volume 2. And this is known as an inverse relationship between pressure and volume. So as pressure increases, volume would decrease. And if pressure decreased, volume would increase. So why is this the case? When we look at a large volume, and we know that pressure is related to the amount of collisions. When you have a large volume, there aren't going to be as many collisions because you have such a large space. So in this diagram, in this particle diagram, you can't have many particles colliding at the same time, if any. Now, when you have a smaller volume, it's so much easier to collide with another particle in this case, and that's where pressure comes in. Pressure is the collisions, and this smaller volume makes it incredibly easy for collisions, so it would have a higher pressure. And the Charles law is going to be the volume 1 over temperature is equal to volume 2 temperature 2. And so this is going to be directly related to each other. So as volume increases, the temperature also increases, and these go hand in hand. And then the last one, but just to mention, constant, so pressure has to remain constant in Charles' law. So if you have a different pressure, as we will see in the Gay-Lussac's law, it's not going to work out. So in the Gay-Lussac's law, we have pressure over temperature, pressure over temperature. And so these two are, again, directly proportional to each other. I'm not going to write it down, but why is it directly proportional? It's because we already know that pressure is collisions, and I've mentioned that multiple times in this video. But temperature is the average kinetic energy. And so if you have more of this energy, especially kinetic energy, that means you're moving at a faster speed. And collisions would therefore be more sporadic. And that would just mean there's more pressure, right? So it kind of makes sense. If you don't have a large pressure, then your average kinetic energy isn't as high, since there's not that many collisions. So it's like this domino effect, especially of Gay-Lussac. So let's start with this first example. A balloon has a volume of 2.5 liters at a temperature of 300 Kelvin. If the temperature increases to 400 Kelvin while the pressure remains constant, what will be the new volume of the balloon? So very important to mention that the pressure remains constant. That's like a key giveaway for Charles' law. So now that we know which law we are using, let's just use Charles' law's formula. So volume 1 is equal to temperature 1, volume 2 equal to temperature 2. And so now all we have to do is fill everything in. So volume 1 is 2.5 over 300 equals volume 2, which we are trying to find, over 400 Kelvin. So that would be 1,000 equals 300 volumes 2. And so that would be around 33.3 liters for volume 2. So they kind of give an idea on if you're right in this case. You know that the relationship is direct, and as long as your volume increases, that should make sense, right? The volume did increase, and we increased the temperature, so the volume should also increase. A gas occupies a volume of 5 liters at a pressure of 2.0 atm. If the pressure increases to 4 atm while the temperature remains constant, what will the new volume of the gas be? So if the temperature is remaining constant, how does this affect? So you would have to use Boyle's law in this one. So Boyle's law is pressure 1, volume 1 equals pressure 2, volume 2. So the first volume is going to be 5 liters. And then the pressure is 2. And the volume is what we're trying to find. But the pressure is 4. It increases to 4. And then the volume, we're asking for the volume. So 10, 4v2, so that's 2.5. A gas is at a pressure of 1.5 atm and at a temperature of 350 Kelvin. If the temperature decreases to 250 Kelvin while the volume remains constant, what will the new pressure be? So now we are going to use Gay-Lussac. So Gay-Lussac would be pressure 1 over temperature 1 equals pressure 2 over temperature 2. So the pressure would be 1.5 over the temperature of 350 would be equal to the second pressure over 250. So if this is going to be a direct relationship, that means the pressure on the second one would decrease. So 350 P2 is equal to 375. P2 is equal to around 1.07 atm. So thank you for watching this video, and I'll see you in the next one.